24 granite boxes, 100 tons each. Their interiors are polished to a mirror finish, and the tool marks show a feed rate of exactly 0.5 millimeters per revolution, equivalent to modern CNC machining. These are not parts of a spaceship or a lost industrial age. They sit in a dark, silent corridor beneath the sands of Saqqara, Egypt. They are the Serapium boxes, and they have been empty for over 2,000 years. Auguste Mariette did not set out to find the boxes. In 1851, the French archaeologist was digging for the Serapium temple itself, the sacred burial place of the Apis bulls. He expected to find a processional avenue, a few statues, and perhaps a few stray sarcophagi. What he found instead, after clearing a collapsed roof, was a narrow hallway lined with 24 colossal granite chambers. The boxes were not placed in a grand burial hall. They were crammed into a tunnel barely wide enough for a single cart. Each box was sealed with a massive lid, weighing another 20 tons. Mariette pried one open. Inside sand. No mummy, no jewelry, no bull, just clean, dry sand. He opened another. Same result. And another. 24 times, the same emptiness. The discovery was published, catalogued, and then quietly shelved. Egyptologists moved on to more productive sites. After all, empty boxes are not as exciting as golden masks. But Mariette had recorded something else, a detail he found curious but could not explain. The interior of every box, he wrote, was smooth. Not just smooth, glassy. You could see your own face reflected in the granite. He assumed the builders had used some kind of polishing paste. He moved on. We have not moved on, because in the 21st century, we have tools Mariette never dreamed of. And those tools have turned the Serapium from a footnote into a scandal. Let us start with the raw numbers. These are not ordinary sarcophagi. The largest box measures 4 meters long, 2.3 meters wide, and 3.5 meters high. That is over 13 feet long and 11 feet high, taller than a double-decker bus. The walls are 30 centimeters thick. Now calculate the volume. Approximately 32 cubic meters of solid granite. With Aswan granite weighing 2,750 kilograms per cubic meter, each box comes to roughly 88 metric tons. The two largest examples exceed 100 tons. Add the 20-ton lid, and you have a total moving weight of 120 tons per unit. Let that sink in. 100 tons is the weight of 3 fully grown African elephants stacked together. And there are 24 of them. That is 2,400 tons of polished, transported, and placed granite just for these boxes. But numbers alone are boring. The real question is not the weight, but the precision. Because if you drop a 100-ton block from a rope, it lands with a crack. It shatters. It does not land with a mirror finish. So how did they achieve that finish inside a tight, enclosed space, with no room for large tools? That question leads us directly to the walls themselves. Take a flashlight into the Serapium today. Shine it into any of the 24 boxes. The light does not scatter. It does not bounce into random directions. It reflects back as a coherent, undistorted beam. That is the definition of a polished, planar surface. In materials science, we measure surface roughness in microns, millionths of a meter. A typical carved stone surface from ancient Egypt, say a limestone wall in a temple, has a roughness of 50 to 100 microns. You can feel the chisel marks with your fingernail. The Serapium boxes, measured with portable profilometers by independent engineers in 2019, show a surface roughness of less than 1 micron. That is the standard for optical grade mirrors. That is the same standard used for precision gauge blocks in a modern machine shop. But here is the killer detail. The polish is not limited to the flat surfaces. It wraps around the inner corners into the 90-degree angles where the walls meet the floor. There is no overspill, no rounding. The corner has a sharp, crisp edge and the polish extends perfectly into that edge without any visible deviation. Try doing that with a sandstone block. You cannot. The abrasive grains would round the corner. Try doing it with a copper chisel. You would leave curved striations. What we see in the Serapium is a flat, parallel, continuous polish that matches diamond-tooled surfaces. And this is where the timeline breaks. Because the Serapium is dated to the 19th dynasty, around 1300 BC, the only abrasives available at that time were quartz sand and emery powder. Both are hard, but neither produces a 1-micron finish on granite. Not in 1,000 years of hand polishing. Now we look at the marks that Mariette dismissed. Modern high-resolution 3D scans have revealed a pattern of parallel, undulating lines running across the interior floors and walls. These are not random scratches. They are tool marks, precise, consistent, and repeated. Each line has a depth of approximately 0.5 millimeters. The spacing between the lines is uniform, about 2 millimeters. And here is the breakthrough. The lines curve in a pattern that indicates a rotating, circular tool, not a straight chisel. A chisel leaves a straight, flat groove. A drill leaves a circular hole. But a rotating disc or a milling cutter leaves a scalloped, curved imprint. That is exactly what the scans show. Now measure the distance between the peaks of these scallops. That distance corresponds to the feed rate, the speed at which the tool advanced across the stone. The average feed rate across all 24 boxes is exactly 0.5 millimeters per revolution. That is the same feed rate used in modern CNC precision milling for hard metals like titanium or hardened steel. Let me repeat that. A machine from 1300 BC with copper or bronze tools managed a feed rate that 21st century CNC operators use on high-performance machining centers. And it maintained that feed rate across 24 different boxes over a production period that likely spanned decades. Not a single box shows a deviation larger than 0.05 millimeters. Coincidence? Statistical impossibility. One box might be a lucky anomaly. 24 boxes, over 4 decades of work with identical feed rates. That is industrial standardization. That is production line consistency. Let us take a step back into material science. Granite is an igneous rock composed primarily of quartz, feldspar, and mica. Quartz has a hardness of 7 on the Mohs scale. Dolerite, the hardest stone used in Egyptian quarries, has a hardness of 6. Copper, the metal of the Bronze Age, rates at 3. Bronze rates at 4.5. You cannot scratch a 7 with a 4.5. It does not work. You cannot carve, drill, or polish granite with a metal tool unless that metal is harder than the quartz crystals themselves. The only known materials harder than quartz are corundum, sapphire/ruby, and diamond. Neither was documented as an abrasive in Egypt until the Roman period. So how was the granite cut? We have 2 proposed mechanisms. 1. Using dolerite pounders to crush the surface, then sand and water slurry to grind it smooth. That produces a pitted, matte finish. It never produces a mirror polish. 2. Using copper saws with sand abrasive, which leaves deep, irregular grooves, not the 0.5 millimeters uniform scallop pattern. The Serapium rejects both methods. The polish is too fine. The feed rate is too regular. The corners are too sharp. It is not a matter of we don't know how they did it. It is a matter of the tools we know they had physically cannot produce these results. This is not a gap in our knowledge. This is a contradiction in our evidence. We return to the emptiness. Mariette opened the first box and found sand. He opened the second, same. All 24 were void of any human or animal remains. No linen, no canopic jars, no gold, no inscriptions of a named pharaoh. Just a clean, sterile, polished interior. Some Egyptologists argue these were intended for apis bulls, sacred animals buried alive. But bulls leave residue, protein, fat, bone fragments. The inside of a bull sarcophagus is organic stained and marred. The Serapium boxes are sterile. No organic stain, no calcium deposits, no bone dust. Others suggest they were cenotaphs, symbolic burials. But a cenotaph does not require a 100-ton precision-engineered box with a CNC finish. If you are building a symbol, you build it cheaply. You do not invest the entire industrial capacity of a kingdom into a box you will never open. The most disturbing theory comes from a 2005 geological survey. The boxes were aligned with the same magnetic declination as the Earth's field in 1300 BC. That alignment is so precise that it could only be achieved with a compass. But no compass existed in Egypt until the Greeks brought it over 800 years later. So we have boxes that 1. Weigh 100 tons, 2. Are polished to optical precision, 3. Exhibit CNC-level tool marks, 4. Are cut from the hardest stone available, and 5. Were sealed with 20-ton lids, only to be found completely empty. That is not a tomb. That is a machine, or a vault, or a test chamber. We do not know, but we do know it is not a grave. Every Egyptologist will tell you the Serapeum was built by ramps, ropes, copper chisels, and generations of slave labor. They will show you wall paintings of men dragging statues. They will quote the numbers, 20,000 workers, 10 years of construction. But not one of those wall paintings shows a man polishing the inside of a granite box with a mirror finish. Not one shows a tool that leaves a 0.5 millimeter scallop cut. Not one explains why the feed rate is identical across 24 boxes built over 40 years. When the evidence contradicts the narrative, you do not change the evidence. You change the narrative. The Serapeum does not prove aliens. It does not prove a lost super-civilization. It proves one thing. We have either misdated the boxes by several thousand years, or we have completely misunderstood the technical capabilities of the 19th dynasty. Either conclusion is revolutionary, and both are supported by the same physical measurements. The Serapeum is still there, beneath the sand, silent and empty. It does not ask to be believed. It asks to be measured. And when you measure it, the numbers do not lie. The question is not, what is this place? The question is, are we ready to accept what the evidence is telling us?